Hello everybody. You have a question over in the chat to introduce our topic. So we're getting more into nuclear chemistry, and so the kind of ticket in the door is what is one way you have experienced nuclear chemistry this week. Okay, we've gone over a couple different, talked about nuclear chemistry the past couple of days, so you should have a good idea. So type in your response there. And if you look over on the side of your screen of your Google, the classroom, Google Meet, is the attachments. Okay. So you have a ticket out the door when we get to it, and you have the notes handout. If you haven't printed it off already, you can print it from there. So we're going to be looking at so here's all your documents. Okay. All right, so we're going to look at half-life problems. Okay. So I'm going to show you how to work these. A second. I think it's ready. All right, so we have these half-life problems here. Okay. And so to do half-life problems, we talked about what half-life means. Oops. Half-life is the time it takes for half of something to go away. So the way we work these problems is you're going to set a little T-chart like this. And you're going to have two categories on your T-chart. You're going to have time, and you're going to have the amount. And before you press the timer on the stopwatch, your start time is always right. Always put 0. And then you'll read the problem. You'll be given two other pieces. Okay, starting amount, and then we have the ending amount down here and the ending time. So you have two pieces of information. You're going to find the third. So an isotope of lucky charnium has a half-life of 120 days. So that's our half-life. Let's circle that. How many days will it take? Will have passed when 50% of the lucky charnium sample remains. So if we start with 100%, that's my amount. I'm going to start that there. And so this, just kind of think through this one. If half-life is half the amount, okay, 100 is 50, we'll get 150 days. So when 50% will be gone. All right, let's jump down to number 6. Okay. This is a good one. So let's set up our chart. Time is on top. Amount is on the bottom. Our start time is always 0. So our leprechaun requests 1 gram of rainbownium has a half-life of 20 minutes. How many grams must be prepared if shipping is 1 hour? Okay, so we're going to start with 1 gram and 1 hour. So 1 hour is our end time. Look, our half-life is in 20 minutes. So let's go ahead and change 1 hour. So time, your directions are time, always add half-life. So we need to figure out what's this number. Well, we don't know what's going on in the middle part of our table. So we do the time first because we have both the front and the back of that. So 0 plus 20 is 20. 20 plus 20 is 40. 40 plus 20 is 60. Yay, we made it. And the amount, you always divide by 2. So 1 divided by 2 is 0.5. 0.5 divided by 2 is 2.5. 0.25 divided by 2 is and it's grams. Okay, so type in any questions you have. Stop presenting. All right. Now that we have gone through half-life all together, you know how to do these half-life problems. Go over to the ticket out the door. Oops, I'm in some trouble. There we go. And over in the ticket out the door, you've got a little exit question. So please do this exit question before you leave the group. And I will be contacting those of you individually who need additional help with the half-life problems based off your ticket out the door. Okay? It's still looking. Okay, have a good day, and I will see you guys soon. There it is.